this video, we're going to look at setting up the ACH580 with intelligent pump control. We are going to talk about the inverter-to-inverter links between each drive and how it communicates to each other. We are going to look at actually programming each individual drive. We're going to use slides and use actual hands-on video. This video will work for the ACH580 and the ACQ580. Both are applicable for this video. It can work on fans and it can work on pumps. ACH580 Intelligent Pump Control. And the agenda for this presentation is to overview the intelligent pump control, program the drives, inverter-to-inverter communication link, programming setup of individual drives including drive name, mode node number, master drive, and preferred pump settings, shared settings including copying and keeping synchronized, total pumps and pumps running, start stops and speeds, transition smoothing. We'll verify the information is being transferred. We'll do the PID setup, and we'll look at parameter groups, group 76 and group 77. We'll do a running example. We'll do a fault example. Now let's go on to a review of what intelligent pump control is. ABB brings you the ACH580 variable frequency drive with intelligent pump control. What's intelligent pump control? Intelligent pump control allows you to control multiple pumps in a highly efficient manner, allowing for system redundancy and ease of maintenance. Intelligent pump control is standard on the ACH580 drive family, and it can control up to 8 individual pumps. The drives are the controllers of the system, removing the need for expensive external hardware, saving you money. And with the ABB moving master strategy, each drive in a multiple pump system can be eligible to be the master drive. This creates a high level of redundancy. If one pump fails or requires maintenance, the other drives in the system can become the master operating the system. So what's a master drive? The master drive controls the system. It regulates the system's speed for optimal energy usage based on process demand. It performs smooth transitions, activating and deactivating pumps. It's responsible for processing the input and output control signals. Intelligent pump control and the ACH580 has lots of flexibility. You can control which drives are eligible to be the master drive. You can determine what's the minimum amount of pumps that need to run at any given time. You can program in for the maximum amount of pumps that can run at any given time. You can set up the system to perform auto change to balance the operation of the system so individual motors and pumps have equalized wear. Individual pump priorities can be set. So if you have pumps with higher efficiency levels, these pumps can have higher priority levels. The system will automatically use those pumps first and use them more often, saving you energy and saving you money. Intelligent pump control is one of the many innovative solutions brought to you by ABB and the ACH580 drive family. In an intelligent pump control system, the drives communicate through an inverter-to-inverter link. This can be done through the embedded field bus terminal on each individual drive, or it can be done through an ABB ACH580 Modbus adapter module. Each drive in the system requires a run command for the IPC logic to function and to use the drive if needed. Default, this is in auto mode. It's done by using DI1. To be used as a master drive, the speed reference must be supplied to the drive. Any safety interlocks or interlocks that should be wired to each drive. The inverter-to-inverter link is done through the embedded field bus, and that's where it controls data and drive status is sent back and forth between the drives. In this diagram, we're showing drives 1 through drive 8 all have the embedded field bus connected to each other. We're showing that digital input 1 for the start-stop is wired to each one of the drives, and analog in 2 will be used for a PID loop wired to each one of the individual drives. This allows any individual drive to be used as a drive master, and with the master strategy, any drive can become the master, allowing for a high level of redundancy. In this example that we're going to use today, the pressure transmitter goes to a single splitter/isolator with an output of 0 to 10 volts being applied to each individual drive. This allows any drive to have the actual speed reference. The relay K is a seal leakage sensor. It is wired to each individual drive as a K1 as run permissive. The start wire and stop is wired to each individual drive. Embedded field bus is wired to each individual drive. And it's looking at drive 1, the termination switch and the bias switch is turned on. Drive 2, the terminal switch and the bias switch is turned off. And all other drives, except for the N drive, would be set to off. On the N drive, the termination switch is set to on, and the bias switch is set off. In this case here, we'll have only 3 drives. And let's continue on with the presentation. Now let's take a look at the individual drives and look at actual programming of the parameters into the drives. Programming the ACH580 Intelligent Pump Control System is simplified through the use of an inverter-to-inverter communication link. This link allows for automatic parameter synchronization between the drives. Program each individual drive for its connected individual pump and motor characteristics, then program one drive for the intelligent pump control features that you want. That drive will automatically update the other drives in the system. Any drive can be programmed to be a master drive. The master drive controls the other drives through the inverter-to-inverter communication link. At this time, we're going to look at setting up intelligent pump control. Each individual drive has been set up for its individual motors and motor parameters and any special parameters needed for the pump or fan that individual drive will be controlling. Now to set up intelligent pump control is easy, and we're going to use what we call the inverter-inverter link to move parameters around. But first we have to set up each individual drive. We start out with menu, primary settings, going down to pump features, select, and at this point multi-pump control is off. I hit select. Pumping mode is off, going down, IPC, Intelligent Pump Control. I select that. Node number. Each individual drive in your system, up to 8 drives, needs to have an individual node number. This will be the first drive, so I'm going to program this one first for node number 1. I'm going to save it. Go on the next. Embedded field bus or FMBA-01 module for a field bus module. In this case here, I have the individual drives wired up through embedded field bus. That's EFB. So the drives are wired for an inverter-to-inverter link through embedded field bus. So I hit next. This drive is now set up for IPC. I have to go to the next drive and start out with the next drive. I do the same thing. Pump features, multi-pump. But here, intelligent pump control, I need to set my node number. My node number needs to be 2. Each drive must have its own node number. I'm going to save this and go to next. Embedded field bus, and that's my communications card. And this pump is done. And I'll go to pump 3 and set pump 3 up. Now, we can do our settings for each individual pump. Settings for this pump, select. Drive name, I can change the drive name. I can call it pump 1, which I'll do right now. Edit. So now it's called pump 1, and it's node number 1. And it can be the master. We look at can be master. Can be master allows the pump to be the master drive. And with our master drive system, if we're going to select all the pumps to be eligible to be master drives, so any pump, if one drive goes down or pump goes down, the other drives can take up the master position. Preferred pump. For preferred pump, we have several options. High, run as much as possible. If you have some higher efficiency pumps, you can set the preferred pump to high on those higher efficiency pumps so they're used more often, saving you money. Medium. In this case here, all of our pumps are going to have the same efficiency levels, so we'll have them set to medium. And then low, it would be pumps that you'd have for some reason that you only want to run at the end and as little as possible. So that would be the low setting. So I'm going to save it for medium. Back. All right. On this pump here, I can go down and I can do settings for this pump. On the settings for this pump, we have the pump name. We can change that. We got the node number, which is node number 2 now, and it can be a master. If I don't want it to be a master or be eligible master, I can uncheck this, but we want to leave it checked. And preferred levels, because our pumps are identical, they will all be medium. So changing the name is easy. Go in and just change the name and type in the new name as pump 2. All right, now it's pump 2. Save. And now it's saying pump 2 on top, pump 2 on top. Do this to the rest of your pumps, so each drive will say which pump number it is. This makes your life easier. At this point, this is done. We don't have to worry about shared settings here. We can go back to the front screen. Okay? What we see now is we see output frequency, our PID loop, which is going to be set in the near future. Right now it's set to Celsius. We're going to set that to pounds per square inch. And not ready, off mode. I'm going back to drive number 1 because I'm going to set the shared settings now. So now it's going to be shared settings. Select. Synchronize settings. We want to select synchronize settings, copy, and keep synchronized. What this does is it copies the parameters from one drive to another drive, and whenever I change parameters on any drive that have to do with the IPC, all the drives end up with the same changes, making it easy to program. I'm going to select AI1 settings, even though I'm not going to program them right now, but I'm going to select them just so if anything's done, I want all the drives to match. Units. At the current moment, my units are incorrect. I'm going to change my units to PSI. Save. Next. Now, total number of pumps is 1. I want to change that to 3 because there's 3 pumps in the system. 1, 2, 3. Save. Now there knows there's 3 pumps. I'm going to always run at least 1 pump. I'm never going to run more than. I can edit that right now. I can go up to 3 pumps. Okay. In this case here, if I set it to run 1, always run at least 1, never more than 3, my system will run 1 pump. And if it needs, as it needs to add more pumps, I'll add more pumps up to 3. In this case though, I'm going to make it so I have a system with an extra pump. I only run 2 pumps maximum. So I'm going to edit that again and set it to 2 pumps. Start and stop. Let's start and stop in speeds. Let's select that. Right now, default is start the second pump at 58 Hertz. I'm going to edit that and do it down to 56 Hertz. So at 56 Hertz, the system will look at starting the next pump afterwards. And I'll do that for the third pump too. And then the stop third pump at, we're going to go 25 Hertz. And this pump here, we're going to go to 25 Hertz too. Now we can set the individual ones you want to, but that's what we have it set to right now. Transition smoothing. This function here is dealing with demand spikes. If you have a demand spike under 10 seconds, it's ignored. If you have demand dips under 10 seconds, it's ignored. In our system here, we're going to edit this, and we're going to have spikes and make the spikes up to 3 seconds. And for our dips, we are going to make them 2 seconds. So there we are. We've set those parameters too. Auto change. When we look at our auto change, we can look at auto change, and at default, the maximum wear imbalance between any individual motor or slash pump is 10 hours. And the maximum stationary time is 0 hours. In our case though, we're going to set our wear imbalance to 20 hours, but we want to make sure that any time that we have a scenario where a pump hasn't run for at least 10 hours, we want it to start up because we have a pump, we're only running 2 out of 3 pumps. So to do this, I'm going to edit this, move it up to 20 hours, save. And because I have it set up the way I am going to put, I want a 10-hour wear imbalance, maximum stationary time. This could be set for a lot more hours than this. Auto change is only below 100%. What that means is if you, in this case here, we have 2 pumps running, and if we have a scenario where our demand has both pumps running at 100%, then it will not do an auto change until it drops below 100%. And at that point, you'll do the auto change. That could be adjusted to like 90% or 80%, just so when you're doing a high demand scenario, you want to make sure you're below that demand when you're doing your auto change. But your auto change in our system actually does smooth auto changing. It will bring up another pump, and it will lower the pumps to even them all out and do the changeover. So, but this is the settings you can set. Now we have the PID control settings in the secondary reference. This is AI in 2. So let's see what we have now. Looking at our system, that's all our settings. Back, 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 and now we're set up. And here's our screen. Let's verify that the information transferred. I'm going to go over here, hit menu, go to primary settings, and I'm going down to my pump features, and multi-pump controls already in place. And I want to look at the shared settings. And when I do that, we have total of 3 pumps. 1 pump always running, no more than 2. Start, stop, transmission smoothing. Well, let's just look at this one right here. Select. That's 3 seconds and 2 seconds. The information went from this drive to that drive. Let's do a quick review. Each drive must have an individual node number 1 through 8, and it must be sequential. If the embedded field bus communication is needed for the VAS, like if you need to use BACnet, then use the FMBA-L1 modules for the inverter-to-inverter link. All drives need to be in intelligent pump control for the inverter-to-inverter link to work. To enable synchronization of parameter groups between 2 or more drives, the group synchronization must be enabled in all drives. Synchronization process uses 2 mechanisms to make sure that the parameter groups are synchronized. When parameter values are changed in any given drive, it broadcasts the changed parameters through the inverter-to-inverter link. In addition, if the drives periodically just broadcast what we call a CRC, a cycle redundancy check, through the inverter-to-inverter link, this allows for a timestamp for the latest edit time of the group. For this information, the drives conclude if the group is synchronized and which drives have the latest parameter values. If the CRC mismatch, then the drives request parameter values from all the drives in the group and pick the ones with the latest values. You can monitor changes in the drive's configuration with the parameter checksum calculations. Pumps are prioritized based on energy efficiency. High, medium, low. High being more efficient and low being least efficient. If all the pumps are the same, set them all to medium. Max stationary time is so that even low priority pumps are exercised often enough to keep them in operational condition. Pressure maintenance pumps like jockey pumps should be controlled separately to provide the necessary control. There is only one active master pump. The master pump controls the IPC system by starting and stopping the follower pumps when necessary and by sending the reference signal to all follower pumps over the IPC network. The master controls the process until the followers have reached the set point. There is no master follower change if the set point is not achieved. Max stationary time is followed if it is set. This is a high priority because it makes sure that the pumps are kept in good condition and not just staying inoperant. After checking the max stationary time, the pump priorities are followed. This makes sure that the pumps with higher priorities are operated more often. If none of the above conditions are set, the system tries to balance the operation time between all the pumps. Let's continue on and take a look at setting up the PID control. Let's look at the proportional integral derivative controller, otherwise known as a PID loop. For setting it up, in primary settings, use the PID assistant. Default feedback is through AI2 and start-stop is through DI1. AI2 input range is selected. Units displayed and input ranges are entered. Set point source can be selected as constant value, control panel, or analog input 1. When the information is entered at the setup complete screen, remember to press done. This must be pressed to enter the data into the drive. More options can be programmed in primary settings or in parameter group 40. Complete the PID settings as needed for the system. You can do tuning, increase the output for feedback greater than set point or feedback less than set point. In our case, we're using pressure, so when the pressure drops and the feedback is below the set point, we want the drives to increase speed, so we want to increase the output when feedback is less than set point. Analog output range for analog output 1 can be set. Sleep function can be at off. If sleep function is turned on, you can program the activation level, the delay time, the boost settings, and the wake-up settings. Now let's go through setting up the PID loop. Let's set our PID control, secondary reference. And what we have here, we can use the assistant, and the assistant's going to tell us that automatically we can have as analog input 2, and start-stop is digital input 1. And looking at this, our analog input's not correct. We need voltage right here, so I use the right arrow, because the right arrow is there, and select 0 to 10 volts. No dip switches, no nothing. I've just changed the input to voltage. PSI is our units. Feedback when AI2 is at a minimum of 0 PSI and maximum of 60. In this case here, I want to make sure 60. I'm going to use the right arrow, and I'm going to change that up to 100, because that's where we're going to have our system at. So, save. And we go on to next. We're going to use a constant value as our value that we need to look for, and that's going to be a set point, and the set point is going to be, I have to back up, set point is going to be 75. Save. Next. So DI1, 75 PSA is our pounds per square inch is our set point. Feedback is AI2. Analog input 2. Done. Now it's saving parameters, and if you see what happened over here, 75 PSI showed up there as our set point. Okay. So now we have that data in place, and it's all been transferred through the inverter-to-inverter transfer system. And I'm going to stop the drives right now. We've been programming the intelligent pump control through primary settings. Let's take a look at the parameter groups for intelligent pump control. Parameter 7602, multi-pump system status, is displayed in text format. And 7611 through 7618, pump and fan status, words 1 through 8, is a 16-bit word. Refer to the manual for what the individual bits mean for each word. 7670, PFC auto change defines ways to do auto change. It allows for more options to be selected than we can select in primary settings. 76101, IPC parameter synchronization. This is actually set up in primary settings also. And 76102, IPC synchronization settings. This is also set up in primary settings too. But 76105, IPC synchronization checksum. This displays the calculated parameter checksum, under the CRC. If the values of this parameter is the same for all drives, then the configuration is also synchronized correctly. Looking at parameter group 77, maintenance and monitoring. 7710 is the PFC runtime change. It enables the reset arbitrary settings of parameters 7711 through 7718. This is pump fan 1 through 8. And this is the running time. You can reset the running time to 0, or you can put in an individual running time for whatever you have. If you replace a pump and fan, you can reset it to 0, so it is set to 0. But if you have a pump and fan that's been used and you know the running time and you put that into your system, you can actually enter that data in. 7720 IPC online pumps. This displays the pumps which can establish a connection through the inverter-to-inverter communication. 7721 IPC COM loss status displays the drive's COM loss status. Both these parameters allow you to look at what's happening with the inverter-to-inverter communication. Let's take a look at the parameters. We're going to do a quick look at the parameter group that has to do with the intelligent pump control. So we can go into parameters, complete list. In the complete list, we have two sets of parameter groups that we can look at here, and that is 77 maintenance and manual, and 76, group 76, multiple configurations, multi-pump configurations. In multi-pump configurations, you can look at the status of many different things. You have the ability to check the node on the individual drives, make sure the master is enabled, your communications, your maximum number of motors, all the stuff that was done in the setup can all be set up here too. And it all transfers over through the inverter-to-inverter communications. There's a couple things you can do here that you can't do up in the actual primary setting setups. And that is, you can look at certain things like, you can set up your, let me get to it right here. You can set your acceleration time and your deceleration times here. You can do an auto change for even wear, and you can edit that. And you can do it in multiple different things. I want everything stop to do auto change, fixed intervals, time functions. You can have digital inputs do the auto change. Okay. And so there's multiple other things you can do, and you can go to other, and other gives you different values and different things that you can do for auto changes, and you know what you can set up for. So it's very, very flexible. So there's different things that you can set up for even wear. And your intervals can be altered here. I can back up, and I can look at multi-pump motor maintenance here. Now we have our running time on each individual motor. And we can reset running times. So if you've changed your motor out or changed your pump out, you can reset your running times here. So you can change the running times, and you can set any running time you want and you can reset individual running times here. So up to your 8 pumps can be reset here. That's multi-pump maintenance. Pump control comes with smooth pump transitions. Let's take a look at what happens when you change from one master to another. The timing diagram shows smooth pump transitions of the pump starting steps. In this case, the process PID output current master has exceeded the start level. The IPC system starts a new pump after the start time delay is elapsed. After the motor magnetization and start rotation, the new pump accelerates to the master speed along with the IPC smooth ramp time. When the new pump is accelerating, the other pumps decelerate to maintain stable output of the system, shown as a normal ramp in the diagram. After the new pump reaches the speed of the current master, the new pump becomes the new master. The new master and all remaining pumps will start to follow the new master drive defined by the process PID loop in the master drive. When you're done programming the drives, turn them into auto. When you put them in auto, this one turned to master. This one's currently in standby. As you turn all your drives on, they will select out what they need to do. So master start delay. Now it's starting a follower. Drive number 2 is the follower this time, and now it's being brought up to speed. At this point, drive 1 is the master, drive 2 is the follower, and drive 3 is waiting at this moment. I am going to fault the master drive, and with the moving master strategy, the master drive 2 or drive 3 will pick up the master position. It depends on where in the queue on the system they're at. So I'm going to fault it right now. I'm faulting drive 1. I've faulted drive 1. It's now faulted. And when I look at here, drive 2 is follower, and drive 3 has become the master. So the master drive has moved over to drive 3. As we look at the motors, drive 1 is stopped, drive 2 and 3 have picked up the work. And that concludes our video on intelligent pump control. Thank you for your time.